Can you see my screen?
Yes, we can.
Okay. Good morning, everyone. My name is Kolawole Oduremi. You're welcome. Today, we are going to dive into infrastructure as code, IAC in short. Specifically, we will be focusing on Terraform, one of the leading tools in DevOps space. So we should ask ourselves, what is infrastructure as code? To start, let's define it. IAC in traditional infrastructure setups, normally we would manually configure servers, networks, and services. And often these tasks are repetitive, and they are very prone to error. These tasks, they are very prone to error. So infrastructure as code came to automate this by allowing us to define infrastructure in configuration files. This code can be versioned, it can be tracked, and it can be reused multiple times without you, so that whenever you want to create another infrastructure instance, you don't need to start from scratch. You don't need to start defining your specifications all over again. The moment you have a code about this, about your infrastructures, you just go back to that code and reuse it. So with IAC infrastructure as code, we can apply DevOps principle to infrastructure by bringing consistency, speed, and automation to the process. Like I already said, the infrastructure as code is the practice of managing and provisioning computing infrastructure using configuration files instead of manual processes. And this in turn brings automation, consistency, and the ability to version control infrastructure in the same way that we do with our application codes. For the programmers among us, or for most of us, must have partake or participate in one or two coding classes before. I think we already defined what infrastructure as code is. It enables organizations to manage their computing infrastructure in the same way they manage application code, which leads to increased efficiency, reliability, and collaboration. So why Terraform? You know that our topic for today is talking about infrastructure as code with Terraform. So why Terraform? Terraform is a popular tool for infrastructure as code, IAC. It is open source, and it is also cloud agnostic. When I say cloud agnostic, I mean you can use it with multiple providers, like cloud providers like AWS, Azure, and GCP, with the same syntax. So the syntax does not change. You can always move it from one provider to the other. Whatever you have defined for your infrastructure, you don't need to, if you want to take it from GCP to AWS, you don't need to change your code. The code still remains the same. Terraform also uses a declarative language, meaning that we define what we want to create, and Terraform handles how it gets created. Like I said, when you want to move your infrastructure from AWS, for instance, to GCP, you don't need to change your code, like I already said. So Terraform will handle that aspect for you. It's going to Terraform is the one that is going to handle how your infrastructure gets created. Um, let's take a look at some of the fundamental components of Terraform to understand how it works. First, we look at Terraform providers. Uh, Providers is just these are just plugins that connect Terraform with various cloud providers. For example, if we are working with AWS, we'll specify that AWS is our provider. The moment we specify this, Terraform handles the rest. Pull it pulls all the necessary connection strings to be able to establish a connection with AWS. The same thing go for GCP and every other cloud providers. Another component to take a look at is resources. These are the individual infrastructure elements like EC2 instances, databases and networks, VPC, and the rest. Resources actually are the building blocks of Terraform configuration. So all these resources, they are the blocks you are going to define in your Terraform code to bring your infrastructure to life. Another component to take a look at is Terraform state. Terraform keeps a record of your infrastructure in the state file. There is a state file where Terraform keeps the records of your infrastructure. This file allows Terraform to track changes and make updates incrementally. As you add different resources, different information, Terraform is keeping record of this information, this in your infrastructure in the state file incrementally. As you add them, it keeps adding them and keeping the record somewhere. Another component to take a look at is Terraform modules. Modules are reusable packages of Terraform code. By organizing your code into modules, you can make it modular, readable, and reusable. Let's take a look at Terraform workflow. Terraform workflow consists of a few simple commands. They are not difficult. They are just simple 4 commands. The first one is Terraform init. Init, like it means initialize. This Terraform init initializes the configuration and installs any required provider or modules. So when you have declared, for example, you have already declared who your provider is, maybe it's AWS or GCP or Azure or any other one. If you have declared it, the moment you are in your work directory and you execute the command Terraform init, it is going to install any required providers or modules that is necessary for you to create your infrastructure. The next one is Terraform plan. Terraform plan previews the changes Terraform will make, the changes it is going to make. It previews the changes that Terraform will make, and this is a safe way to see what will happen before it's actually applied. The moment you execute the command Terraform plan, it's going to bring out everything that you have written in your code, in your modules, your variables. It's going to bring them out. even if you have if there is a mistake in your code right there before you go to the next stage, Terraform plan is going to show it to you that okay, there is a block of instruction here that does not meet the rules, whether that infrastructure cannot be provisioned. It's going to tell you, it's going to show you where you are making mistake so that you can review your code and make correction. Then Terraform apply, execute the changes and provisions your infrastructure. The moment you uh, execute the command, Terraform apply. Whatever you have written in your block of code, Terraform is going to send it to the provider, and it's going to perform those actions. Whatever you ask it to do, whether you ask it to do, create a server for you, a database, whatever you have defined in your block of code, Terraform is going to send that instruction to your cloud provider. Then your cloud provider picks it up and creates the infrastructure for you. The next one is Terraform destroy. Terraform destroy removes all resources defined in the configuration. It is a great command for clean up when resources are no longer needed. Let's say what you needed your infrastructure for is for to run a test. After you have done whatever you want to, I mean, after you are done with the infrastructure, you don't want to incur costs. You just go straight and destroy it by hitting just that one command, Terraform destroy. So it saves you the stress of going to your cloud provider and you are going from one page to the other, uh, shutting down or deleting a server, going to database to go and stop it and all that. Terraform is going to destroy everything at once without you going from one spot to the other. What are the benefits of infrastructure as code with Terraform? Now that we understand the basics, let's look at the basic benefits. I mean, the benefits of IAC with Terraform. Number one is consistency across environments. By defining infrastructure as code, we can easily replicate environments like um, development, staging, and production, ensuring that they are consistent. Since everything is in a code, so anytime you deploy them, it will still be the same. So there will be consistency in what you are doing. It should not be like, oh, I've forgotten what I wrote here, or I've forgotten how I did this particular, how I provisioned this particular aspect of my infrastructure. No, there's nothing like that. Terraform already has all those information. So there will be consistency in whatever infrastructure you deploy across our environment. The next one is version control. Since Terraform configuration are files, they can be stored in a Git repository, making it easy to track changes. You can track changes. You can revert to previous version and collaborate with team members. The next one is multi-cloud support. Terraform's provider agnostic approach means we can use the same syntax across AWS, Azure, GCP, whatsoever, and even on-premises solutions, reducing the learning curve for multi-cloud environment. So you don't need to go and learn a special way of coding Terraform for AWS and learn another one for GCP. You see the same code, the same way you code it for AWS, the same way you use it for GCP, Azure, and every other cloud providers. What are the common uses of infrastructure of as code. Some typical scenarios where Terraform access includes infrastructure provisioning. We have already mentioned that. Setting up environment from scratch, such as creating VPC, subnet, and security groups in a repeatable way. Multi-environment management, yeah, using Terraform to create, update, and destroy identical environments for development, staging, and production. Then automated scaling, you can use it for provisioning or to scaling resources, load balancers, and monitoring resources for scalability and reliability. What are the essential best practices? Uh, we use module for, make sure you use module for reusability. You organize your code into modules. For example, if you deploy networking resources, you create a module for your VPC setup and reuse it across every other project. This is going to keep your code dry. Dry means you don't repeat yourself. And this is very easy to maintain. You use it for remote stage storage. For collaboration and consistency, you store your Terraform state remotely. This prevents conflicts when multiple team members are making changes and ensures that the state is backed up somewhere. Um, it can be on AWS S3. It can be that backed up on Terraform Cloud or Google Cloud Storage, as the case may be. Then also you can implement inputs, variables, and outputs. You use variable.tf to make your configuration adaptable. Then you define output.tf to expose key information about your resources. This makes configuration flexible and enables you to reference key details across multiple modules, across modules. Another essential best practice is you make sure you plan before you apply. Like I said before, after you have written all your code, the moment you execute the command Terraform plan, the reason why you are running Terraform plan before you are planning before use apply is because you want to be sure that what the code you have written is correct. So the moment you execute Terraform plan, is going to let you know everything, even if it's correct or not correct. It's going to show you that okay, this is what these are the instructions you asked me. I mean, the infrastructure you have asked me to deploy. It's going to list all of them one after the other. So if you have made mistake, you can actually go through it and check your values properly, whether they are correct or not, before you go ahead and apply. Another practice is consistent naming and tagging. Uh, this helps with cost tracking, resource identification, and access management. Um, we need to make sure that our naming and tagging are uniform across our infrastructures. Uh, in summary, to wrap up, Terraform enable us to manage infrastructure with consistency and efficiency through code. Our key takeaways from this include Terraform core components, which are providers, resources, states, and modules. Then the importance of modular code, remote state, and planning before applying changes. Then by following best practices, we can make Terraform setup scalable, maintainable, and resilient. Thank you. If you have questions, you can shoot.
All right, thank you so much for the presentation. So you can go ahead with your questions maybe before people ask questions.
Okay, I have two questions here. The first one is, what is the main purpose of infrastructure as code? Option A there, to deploy infrastructure manually. Um, okay, Blessing says B. Nafisat Brian says B. Victor Okonkwo B.
So we have so many of us saying B. Tell
It's,
us we are right.
yes, you are right.
All right, thank you.
Right. Okay. The second question is, which Terraform command initializes the configuration and downloads necessary provider plugins? Okay. Keep the answer coming. Okay. Are these the only people in the on the call? Okay. Okay.
Yeah, somebody different has said B.
Yes. Chill Ikechukwu. Thank you very much. The answers are correct. That means you guys really follow. Thank you very much. So you can if you have any questions before you ask a question, I think we are going to have part two of this another time where we are going to do practical demonstration of what I've discussed today so that it will make sense.
All right. Thank you so much. So please, if we have questions, you can ask before we end for today.
Yeah, I have a question.
Okay, Hamza, please go ahead.
Yeah, my network was seriously glitching when he was speaking, so I couldn't get some points well. My question is, um, you mentioned something about using Terraform for data, for building and codes and data, stuff like that. I would like to ask,
What?
can use? Yeah, what I said.
Continue.
So my question here is, can one use Terraform to to create a backend for data, kind of like that?
I don't get your question.
Did you get my question?
It's keeping. I mean, your
Yeah,
network is
I think it's
keeping.
my fault because my network was.
Hello. Okay.
So Hamza, I think your voice is low. Perhaps you can type so maybe we can read what you're.
Yeah, let me type it out.
All right. Hi, Justin. Were you trying to say something as well? Oh, you had.
Yeah, trying to say, based on what I understand he was saying. Let him type again, but I think he was saying if it can be used as a backend framework, something like of that sort.
Yeah, something
Um,
like
yes.
like that. That's my question.
Okay. I don't know. Kolawole, please, do you understand? Is it explicit enough for you? Hello? All right. So please, Hamza, please type it so that maybe there's a glitch somewhere. We can just see the message and respond.
Let him type it.
Okay. My own question is what's the advantage as Terraform got over its competitors like GitHub and the other.
The major advantage of Terraform is it's open source, basically.
Okay, so that was just a straightforward answer. Justin, have you gotten the answer?
Yes, I did.
All right. Okay, please, any more questions? Hamza, we're waiting for you to type so we can respond.
For Justin, apart from being open source, it can, it's for others that are just unique for a particular cloud computing provider, like AWS has their own, forgotten what it's called, and others they have their own too. But Terraform, it's it has multi-cloud support, so you can use it for every other cloud provider. So it's not just unique for a provider only. Yes, somebody already mentioned for AWS. It's cloud formation. Yes, thank you, Tolulokwe. Okay, so
Okay.
I get your question now, Amsa. Can one use Terraform to create a backend where one can receive data? Well, if I understand your question properly, I mean, Terraform itself is not a backend framework. It's only used for defining and provisioning and managing infrastructure. That's what it's all about. But then you can also put your scripts while you are defining your infrastructure. You can ask, you can have your configuration file. You can put commands there that when it's provisioning the infrastructure, you can install this, you can run this command and all that. But so Terraform is not a backend framework.
Okay, so please, for those persons that do not know Kolawole, he's part of the DevOps team, and he's making a presentation on what actually happens in the DevOps team. So perhaps maybe you may be wondering, you may desire, all right, to be part of the DevOps team. These are part of the things you'll be doing. Okay, sorry to interrupt, please. Okay, you still have another question. Hi, Kola, please, you have another question in the chat box. Listen. Me, I have just one question. So my one question is, are there challenges implementing AIC? Are there any form of challenges? Okay, we are speaking. I guess you're muted. Please check. Yes.
Okay, can you hear me now?
Yes, we can.
Okay, the challenges are just how you undo the state management. I mean, how you undo it handles sensitive information,